In this video you will learn in 5 minutes the basics of the resistor color code and how to use it for different types of resistors. These are resistors. These resistors have no markings, therefore it is not easy to find out the resistance values. Therefore, early in the 20th century, the Radio Manufacturing Association created the electronic color code to quickly identify resistance value and tolerance. Now, how to read the color band? The color bands represent different values. This table, which is also available on resistorguide.com, is very useful to decipher those values. Some bands indicate the significant digits of the resistance value, a multiply factor, the tolerance, or for special resistor types the temperature coefficient or fill rate. Now we will take a look at a resistor to show how the table can be used to read the code. Let's take an example. This is a 4-band resistor, the most common variation that exists. The first band represents the first significant value. By using the color code chart, we find that the first significant value for a green band has the value 5. The second band represents the second significant value and has the value 6. For a 4-band resistor, the third band is the multiply factor. Red means a multiply factor of 100. The fourth band represents the tolerance, and gold means a tolerance value of 5%. The resistor has a value of 56 or 56 times 100 or 5600 ohms with a tolerance of 5%. We know that the green band was the first band and not the golden one. The increased space between the third and the fourth band indicates the reading direction. Furthermore, the first band cannot have a golden color, and therefore the green band must be the first band. If the fourth band is not colored, we have a 3-band resistor. By looking in the chart, we see that the non-colored band means that the tolerance of the resistor is 20%. The resistance is still the same, but the tolerance has changed. Nowadays, this is nearly not used anymore. For example, in antique radios you can find 3-band resistors. Lower than 3 bands does not exist, with one exception: a 0 black band. This is also called a 0 ohm resistor. Let's consider a 5-band resistor. The extra band is sometimes added for high precision resistors. Instead of 2 significant digits for the resistance value, this type of resistor has 3. So, the first 3 digits represent the significant values of the resistance, the fourth the multiplication factor, and the fifth the tolerance. Again, we use the color code chart to solve this example, and the solution is 147 ohms with a 0.5% tolerance. This is a preferred value from the E192 series. An exception to this is the 5-band resistor with a 4th band of gold or silver. In this case, the 4th band represents the tolerance, and the 5th band the temperature coefficient of resistance. Using the chart, we see that this resistor has a resistance of 1.4 kiloohms with a tolerance of 5% and a temperature coefficient of 20 parts per million per Kelvin. It is always a good practice to check the specifications of the manufacturer for any special rules to read the code. Even resistors with 6-band exist. Normally the bands represent the first significant value, the second significant value, the third significant value, the multiplying factor, the tolerance, and the temperature coefficient of resistance. However, for military specifications, sometimes the failure rate is used. The different values can be read from the table, and the final resistor value is 3210 ohms with a tolerance of 5% and a temperature coefficient of 50 ppm per Kelvin.
Let's try some examples. Here is a resistor with a color code brown, black, red, gold. The first band is brown, which is 1, the second band is black, which is 0, and the third band is red, so the code is 102. The third color, or red, represents 10 raised to the 2 power, or 100. This is the same as 2 more zeros, so we have 1000, or 1000. The fourth band is 5% tolerance, so a brown, black, red, gold resistor is 1000 ohms plus or minus 5%. Now 5% of 1000 is 50, so this resistor can have a value from 950 to 1050 ohms. Here is another resistor: yellow, violet, red, silver. Yellow is 4, violet is 7, red is 2. So this is a 4, 7, and 2 more zeros. The first 3 colors represent 4, 7, and then 2 zeros. So this is a nominal 4700 ohm resistor. The fourth band is silver, so this resistor has a tolerance of plus or minus 10%. So we have a 4700 ohm resistor with a 10% tolerance. Now 10% of 4700 is 470, so this resistor is guaranteed to be within the range of 4700 ohms plus or minus 470 ohms, or 4230 to 5170 ohms. Here is another resistor: white, violet, black, gold. White is 9, violet is 7, and black is 0. So the color code reads 970. It is a common mistake to interpret this as 970, but remember the third digit is the number of zeros, so 10 raised to the 0 power is 1. The multiplier is 1. There are no zeros appended to the digits 9 and 7, so it is just 97 ohms. The fourth band is gold, or 5%, so this is a 97 ohm resistor with a tolerance of plus or minus 5%. 5% of 97 is 4.85. If we add and subtract that from 97, that means this resistor value has to fall within the range of 92.15 to 101.85 ohms. Another example: yellow, violet, orange, gold. That is 473, or 47 with 3 zeros after it. That is 47,000 ohms, or what we would call 47 kilo ohms, or 47 k ohms for short. This resistor has a tolerance range of 47K plus or minus 5%, which equals 44,650 to 49,350 ohms. Another example: violet, green, blue, gold. This is the code 756, or 75 with 6 zeros after it. That is 75 million ohms. Or we can call it 75 mega ohms, or 75 m ohms for short. Notice the capital letter M. Here is another 4-band resistor with low valued resistance. Its colors are green, red, gold, silver. Green is 5, red is 2, gold in the third band is a multiplier of 0.1. So the code reads 520.1. And so we multiply 52 by 0.1, giving a nominal value of 5.2 ohms. The fourth band is silver, so this is 10%. 5.2 plus or minus 10% gives us a range of 4.68 to 5.72 ohms. Therefore, to be called a 5.2 ohm resistor with a tolerance of 10%, the actual value must fall between 4.68 and 5.72 ohms. To review, 4-band resistors consist of 2 color codes representing the first 2 digits of the number, followed by a multiplier, and then the tolerance band. Not all resistors have a 10 or 5% tolerance bands. Many years ago, some resistors had a 20% tolerance, which was indicated by not having a fourth color band. You might find a 3-band resistor in an antique radio or television. For most applications, 5% resistors, or 10%, is more than adequate, but some requirements a more precise resistor must be used. Precision resistors commonly use a 5-band color code. For precision resistors, the first, second, and third bands give the first 3 digits of the resistance value. The fourth band is the multiplier band. The fifth band is the tolerance band. A brown band represents a 1% tolerance, a red band 2%, a green band 0.5, blue 0.25, violet 0.1, and a gray band represents 0.05% tolerance. For example, the first 3 bands of this resistor indicate the first 3 digits, 200. The fourth band, the multiplier band, is brown for 1, or 10 raised to the 1 power. In other words, just 10. So we get 200 with another 0 after it, or 2000 ohms as the nominal value. The fifth band is violet, indicating a tolerance of 0.1%. So this resistor has a value of 2000 ohms plus or minus 0.1%. This resistor is guaranteed to be within 0.1% of 2000 ohms. To calculate this, we convert 0.1% to a decimal number by dividing by 100, which gives 0.001, and multiply by 2000 to get 2. So this resistor is guaranteed to be 2000 plus or minus 2 ohms. It can be no less than 1998 and no greater than 2002 ohms. What has been described in this presentation is the most common ways that color codes are used on resistors. There are other uncommon variations, such as precision resistors with 6 bands, including a band after the tolerance band that indicates temperature compensation or quality codes that are not standardized. Also, some resistors do not use color codes, but have a number printed on them. This tiny surface mount resistor has 100 printed on it. It uses the same coding system as color codes. This one is 10 with 0 zeros after it, or just 10 ohms. This surface mount resistor has 151 printed on it. That would be 15 multiplied by 10 raised to the 1 power, or 15 times 10. In other words, 15 with 10 after it, 150 ohms. Surface mount resistors are sometimes called SMT, surface mount technology, or SMD, surface mount device resistors. Surface mount technology is used in all sorts of devices which must be small in size. Large power resistors also have the resistance values printed on them. Since there is plenty of space, they are often printed without using any scientific number code. Having learned the common color codes, you will be well prepared for selecting the most common electronic component, the resistor.